Section 6.3 arc length. In this section, we'll find the length of the curve in the graph of y equal fx from a to b using the same technique, the limit of Riemann sums. So we'll begin with partitioning. We partition the interval into n subintervals. Then at each point, we evaluate f value, become y. yk is f of xk. Then xk, yk, the point pk should be on the curve. Here, from a to b, we make a partition, and for each xk, we try to get the function value yk. Then the points must be on the curve. Now, for each subinterval, here the length of the curve will be approximated by the length of this line segment. And for example, in the kth subinterval, here, if we are putting this right triangle, making right triangle, then that will be delta xk. This height must be delta yk. By using Pythagorean theorem, length of this line segment must be here. Now, in this formula, there is square root of delta xk squared plus delta yk squared. That is a simple Pythagorean theorem. Now we have to simplify this one by using mean value theorem. Okay, let's recall the mean value theorem. In Calculus 1, you learned this one. Okay, and now y equal fx is given in this way. For example, y equal f of x. Now here, from a to b, we are considering now average slope here. So the average slope will be given in this way. That is now f of b minus f of a divided by b minus a. That is average slope. This average slope is the same as the derivative at some point. If f is continuous and differentiable, then we can find some point c such that the derivative at c is the same as the average slope. In this case, that is now c. Here, there's f prime at c. That is the mean value theorem you learned from Calculus 1. Now, for each subinterval, now that slope is same as at some point ck, the slope of at some point ck. So that is exactly here, delta yk over delta, okay, originally that is delta x, okay. Now delta xk is the same as f prime at ck. There is some point ck between xk minus 1 and xk. Now we multiply delta xk the other side so that we reach at that. Now we replace delta yk with that term to get here, and eventually delta xk can go out of the radical. So we reach at that one. Now that is the length of the line segment on the kth subinterval. Now we add them to get the Riemann sum. That is the Riemann sum. And when you get the integral and taking limit as n approaches infinity, then ck becomes x and delta x becomes dx. So we reach this formula for the arc length and for y equal fx from a to b. So integral a to b square root of 1 plus f prime squared dx. Of course, f prime can be written down dy over dx. That's arc length. If we change coordinate, then here the function must be x equal g of y. And now here from c to d, then the arc length must be here integral from c to d square root of 1 plus g prime y squared and dy. Just simple, the coordinate change can make this formula. Okay, let's try to solve some examples. Find the length of the curve y equal 2 over 3 x to the 3 over 2. So let's try to get y prime, that is here, okay, 3 over 2 will come out, then cancelled with 2 over 3 and x half power. So 1 plus y prime squared is same as 1 plus x. So here the arc length is same as from 0 to 2, and x is from 0 to 2, right? And then square root of the term 1 plus x dx, which is, now we have to find the antiderivative, that is 1 plus x and power 3 over 2. If we put here 2 over 3, then that is antiderivative and evaluation here from 0 to 2. Okay, so that is 2 over 3. And now once it is 2, then the value 3, so that 3 square root of 3, and once it's 0, then 1, so that 1 here. Okay, that's the final answer. Okay, let's try to find the length of the curve. Okay, y is given as a function of x, and x is moving from 1 to 2. So just we'll do it algebraically, the same as earlier. Y prime is same as x squared, right? And then minus 1 over 4 x squared. So 1 plus y prime squared is same as, now 1 plus, okay, here x squared and minus 2ab, so that is half. Okay, there is minus, so that minus half, 2ab is half, okay, now plus b squared, which is 1 over 4 x squared. Okay, now, okay, here, there's 1. We'll add this one to here, minus half, then here, and then it will change it into, rather than this one, we write down here, okay, that is plus half, right? Okay, now this portion is coming from that squared. So that once you start thinking, plus, then that must be half. That means that this whole thing is the same as now x squared plus 1 over 4 x squared, right? We can get it. So here, now arc length must be integral from 1 to 2, and then square root of this one is same as x squared plus 1 over 4 x squared. So that is now 1/3 of x cubed, and that is minus 1 over 4x, and from 1 to 2. So that is same as, now if x is 2, then 8 and minus 1. So that's 7 over 3 minus 1/4 is there. 1 over x, that is once x is 2, then half is 1, then minus 1. If you simplify this, then that will be the answer. Okay. Okay, let's try to solve that one. Now this is x is a function of y, and y is moving from 1 to 9. Okay, for that one, we rewrite this one. That is 1/3 of y to the 3/2. Okay, and then, okay, 1/3 will be cancelled out, and minus y half. Okay, so let's get x prime. Of course, with respect to y, we are differentiated. So that one is same as half. That is, okay, after multiplication, we have half and y to the half power. And that is minus, now half and y to the minus half power. Okay. So we can get, for example, okay, half is there, and y to the half minus y to the minus 1/2. Okay, so 1 plus x prime squared is the same as 1 plus, now 1/4, that's squared, and then now we make a square, so it's y, and 2ab, so that minus 2, and here square will be plus 1/, okay, y to the minus 1. Let's try to write down that way. Y to the minus 1. Okay. That is coming from square of that, right? Square of that is this one. Okay. Now, that is with a quarter, that is now minus half. So same as earlier, we try to add this 1 to over there minus half. Then that'll change it into half. Then it's same as, in fact, now that term will be the same as square of this term with a minus replaced with positive. So that this is the same as now in half and y to the 1/2 plus y to the minus 1/2, and whole thing squared. Right? So from this one, now the arc length will be from 1 to 9, and half of here y to the half plus y to the minus 1/2, and dy. Okay, the computation of this one is not so complicated, so you can finish it yourself. Okay, let's go to the part C. Okay, now for this one, the same way we start with x prime. X prime, that is same as 3/2 will come out, then cancel with this one, and then now that is y minus 1 half power. So here 1 plus now x prime squared, then that is the same as 1 plus now, okay, that is power squared, then that is y minus 1, so that we have y. Okay, quite simple. So here the arc length is same as square root of, okay, square root of that, but anyway, lower bound is 16, upper bound is 25. 16 to 25, and square root of y dy, right? So that is same as, now, okay, this is y to the 3/2, and here 2/3. That is antiderivative, and here now 16 to 25. So that 2/3, and once it's 25, then now that is 5 to the 3, so that is 125. And once it's 16, then 4 to the 3, so that is 64. Okay, you can simplify this one. Okay, here we'll define arc length function rather than the integration is now originally for arc length from a to b. The formula is now integral from a to b rather than b. We try to compute the arc length some point x, start from some point x between a and b. Then that is arc length function. Yeah. Now, so S of x is defined in this way. So once the curve is given, for example, in this way, and that is now a, and that is b. Then for some x, we try to get length from here to there, and that is arc length function S of x. Now, once we are using fundamental theorem of calculus, then now with the derivative with respect to x, we can get that one. So here, the differential of the arc length can be defined here. ds is now square root of 1 plus f prime squared dx, or now f prime can be written as dy over dx. Well, you can write here now dx can go inside, then here you can write down here ds is the same as square root of dx squared plus dy squared. You can memorize in this way. Like in Pythagorean theorem, earlier we used, when we start with the arc length computation, that's now for each one, that is a sort of playing the role of ds, and that is now dx squared plus dy squared. Okay. Okay, so we define here differential. Now let's try to solve this problem. Find the arc length function for the curve taking a as the starting point. So here the function, the curve is defined from 1. Here that is now 1 is a. Okay. So we have to find that portion first. So f prime, so y prime equals same as, okay, that is x squared, and 3 will come out, so that is 4, right? And then minus 1 over x squared. Now 1 plus y prime squared is same as 1 plus, okay, x squared over 4 squared minus 2ab and ab, and then minus half, and plus here 1 over x squared squared. Okay, and as we did earlier, now here that minus 1 is added to over there to become this term plus 1/2. But this can be obtained when this is positive and squared. So that means that this is same as x squared over 4 plus 1 over x squared and squared. Right? So the arc length function is defined in this way. S of x is the same as from 1 to x integral, and then now we put here this one as a function of t, so that is t squared over 4 plus 1 over t squared, and square root of that, so that we ignore that portion, and dt. Right? Okay, so we have here now, that is t cubed over 12, and that's minus 1 over t, and here from 1 to x. Now, once t is x, then that is exactly t, okay, not t, must be x. That is x cubed over 12 minus 1 over x. And once now t is 1, then that is 1 over 12 minus 1. So that finally we can get that one. This portion becomes here plus 11 over 12. So we can get that one. Okay, this is s of x here. Now, for the curve, and yeah, that one. Okay, let's try to visualize that. Once x equal 1, x is 1, then the value will be, the curve value will be a little bit larger than 1 here. And then now, is I guess, in the beginning, this is decreasing, and later on is increasing, so that it looks like it's decreasing and coming up. From here, once you have x, then the length of this one will be that one. So that once you try to check the length as at 1, then it should be 0. Of course, over there from, okay, let's try to get here as 1. Then that will be 1 over 12 minus 1 plus 11 over 12. That must be 0, right? So the S1, because arc length, we begin this point, so that at the starting point, the arc length must be 0, and then increasing along the curve over there, okay? So that's the end of the section. Thank you.